Okay, so welcome back to part two of chapter two's lecture. Last time we left off, we were talking about correlation and some of the problems that come with correlation, especially in regard to determining causality or making any claims about causality. So let's pick up from where we left off. This lecture we'll try to wrap up. I'll try my hardest to make it a little shorter than the last one, but at most the same length. So we've at least broken into two manageable pieces. So you don't have to listen to me talk for 2.5 hours at a time. Okay, so after correlational research, your chapter or in the book starts discussing experimental designs. And experimental designs are the gold standard when it comes to research, particularly in social psychology in general. Really, experimental designs are where it's at. So there are two essential characteristics of experiments that make them very different from the other research designs that we've spoken about already. Number one, the researcher controls the procedures and the variables. So, experimenter control. This is something that we have not seen with descriptive research, something we have not seen with correlational research. So, as researchers, we control the procedures and the variables. And we'll see in a moment there are two variables that we are most interested in: the independent variable and the dependent variable. Another characteristic of experiments are that participants are randomly assigned to the conditions of the experiment. So they're randomly assigned to the conditions or the groups that we are interested in studying. So one thing that we should note is that there is a difference between random assignment and random sampling. So when we talk about sampling in general, this refers to how we obtain our participants. In an ideal world, we would have random sampling. We would obtain our participants for our study in a completely random fashion. The problem with random sampling is that it means we would have to have access to every person who we're interested in studying, and every person who we are interested in studying would have an equal chance of ending up in our experiment. So let's just let's use depression as an example, right? So there are tens of millions of people who are suffering from depression at this moment. Some of us are among them, right? If we were to do a study to see if some new treatment, and maybe it's a social psychological treatment, right, that we develop, if this new treatment is effective in treating depression, if we were to use random sampling, we would need to identify every single person who has depression, who is suffering from depression right at this moment. Let's say we could give them a number, randomly assign them a number, and let's just say we're going to pick 100 people to be in our study. We would need to randomly choose 100 people from those tens of millions of people who have depression in order to be in our study, in order for us to have true random sampling. So random sampling, you can see, is damn near impossible to do for a lot of studies and for a lot of reasons, right? Number one, how are we going to find everyone who is suffering from depression? Some people who are suffering from depression don't even know that they're suffering from depression. Even more people, most people are never even going to get receive treatment for depression. So how we even identify those people? And think about the time and the money and the resource it would take to contact tens of millions of people, all for the sake of us having this massive pool that we're just going to randomly select 100 people from. So random sampling would be ideal, it would be wonderful, because that means the people who ended up in our sample were randomly selected from that population that we are interested in, all of the people who have depression. But it's just so impractical, and it's almost never done for experimental designs. And that's okay. I mean, it causes some limitations that we can address, but what is really important is the notion of random assignment for experimental designs. When you're doing survey research, you better have as random as possible of a sample if you want your survey results to mean anything. So this is why we often see a big discrepancy between polling when it comes to elections, right? In the polls were a little better this time around, but in 2016, all the polls had Hillary Clinton, beating Trump by, not all the polls. There were a couple who got it right, but the vast majority of the polls had Hillary Clinton beating Trump by pretty safe margins, 4 or 5 points, right? Above the margin of error in there. The problem, in hindsight, people are still trying to figure out what the problem was, because clearly Trump won, right? So the polls were wrong; they were off, and a big part of that is traditionally these types of political polls are done using landlines, so they're not really capturing everybody, because how many people have an actual landline in the house? Most of us just carry around these things, right? Most of us just have these. So polling is getting better, but in a situation like that, when we're trying to capture what the population is thinking or feeling, random sampling is going to be more important. When it comes to experiments, we're actually more interested in how our manipulation of a variable, that's how that affects the dependent variable, right? So we're more interested in an experiment where we're more interested in the variables involved, not necessarily the people who are involved. That being said, it is still very important that we try to have a very representative sample. We want our sample to look very much like the population and to be as random as we can make it. But once we do have our sample, once we do have those 100 people and we need to assign them to different groups, whether they're going to get our new treatment or whether they're going to get a placebo, they're going to be part of a control group, that assignment, the way we assign those participants, must be random. And there's no excuse not to do it, because you only have 100 people right now, right? Not tens of millions. So this is something that's very easy for us to do, and it has to be done. We'll see why in a moment. But without random assignment, your experiment is garbage, essentially. That might be very strong of me to say, but at best it's no longer an experiment. It could be a quasi-experiment, right? So random sampling is concerned about how we get our participants. Random assignment is concerned about how we assign them to conditions once we actually have our participants. Okay, so let's take a look at some differences between correlations and experiments, or correlational research and experiments. So what does it involve? Let's start with correlation research. Correlational research involves measuring variables and the degree of association between them. So measuring two variables, we're talking about bivariate correlation here, so two variables, and measuring how much are these two things related, how much do they go together. In experimental research, what is involved? Random assignment to conditions and control over the events that occur, determining the effects of manipulations of the independent variable, which we'll talk about in a moment here, on changes in the dependent variable. So we'll talk about both of those in more detail, but as a heads up, the independent variable is what we are interested in studying, or what we are interested in manipulating as researchers, right? So before I said, using our depression example, if we came up with some new type of treatment, that's what we would be manipulating. Some people will get the treatment, some people won't get the treatment, and then we will measure their depression afterwards. So how the people feel at the end of the study is quote-unquote dependent on which group they were assigned to. It's dependent on that variable that we as researchers manipulated, which is the independent variable. So we can, as a way to try to remember the difference between these two, independent variables are manipulated, dependent variables are measured. Okay? Second, what is the biggest advantage of using these methods? Well, with correlational research, we spoke about this already, right? It enables researchers to study naturally occurring variables, including variables that would be difficult or impossible to manipulate, or variables that would be incredibly unethical to manipulate. So if we wanted to study the effects of smoking, we probably should not conduct an experiment using humans. Now, there's tons of experiments using various animals and smoking. And for decades, the tobacco industry said, well, that you did that study on a chimp or a monkey, research monkey. There's no proof that that would happen in a human, right? So ultimately, the tobacco industry lost that battle. But in a sense, they were right, even though they were full of shit, right? Because at that point, it would be incredibly unethical for us to randomly assign a group of 10 or 12-year-olds to a smoking condition and a non-smoking condition, have them smoke for their whole lives, and then, measure the effects of that smoking. That would be totally unethical to do. So all we really had at that point was correlational research. So when we say that correlation does not cause or does not imply causation, that's what we're going to stick to for now. Once you start getting into more advanced statistics, and once you start seeing certain patterns that exist over decades, and once these are the same results that we see in animal models, correlation might not prove causation, but it sure as hell can start to imply it very convincingly. But we're not going to go there. For us, correlation does not mean causation for now. Okay? So what is the biggest advantage of using experimental designs? Well, of course, this is the gold standard. It can determine cause and effect. We can, with an experiment, we can say this variable causes that to happen, right? Or another way of putting it is, when I make changes to this variable, I will see changes in that variable. This causes that. That's pretty profound. That's actually what makes experiments kind of cool, right? It's like we're able to make these types of causal statements. So pretty neat, right? Pretty neat. So let's take a look at the difference between laboratory and field experiments. So experiments don't necessarily have to be done inside of a laboratory. Experiments can be done out in the real world. There are benefits and minuses and, say pros and cons to each of these. So let's take a look at what happens in a laboratory setting. Number one, a laboratory gives experimenters a ton of control over the setting. We get to even manipulate how much light is coming into, how much light participants are exposed to. We get to monitor the temperature. We get to keep a whole bunch of things constant. We basically get to take out a whole bunch of these, what we call extraneous variables. So extraneous variables are anything that can influence the results of our experiment. Laboratories are wonderful, say, tools or wonderful settings in which to control all of those extraneous variables to make sure they're not influencing our results by holding them constant across every condition there. Laboratories also let us measure participants' behaviors much more precisely, right? We have full access to participants. It allows us to monitor their behaviors, or even to administer different types of tests or surveys or questionnaires in a much more precise environment, right, with less distractions going on. Also, laboratory settings allow us to keep conditions identical for all participants. No matter which condition you're in, you're going to still have the same exact environment in which you're participating in. So field research, some of the benefits here are that it's taking place in the real world, outside of a laboratory. One of the say, downfalls, or one of the cons of disadvantages, that's the word I was looking for. One of the disadvantages of laboratory studies are, you get all of this control, you get to eliminate all of these variables, but you know what? In the real world, all those variables are there, right? So laboratory studies are often criticized for being not very realistic. That people don't live and socialize and work and play inside of laboratories, inside of controlled environments, right? We live in the real world. So laboratory studies might be a little too artificial, and that can cause some problems. We'll see in a moment. It could cause some problems in terms of, how certain are we that what's going to happen when we remove all those controls, all this control that we had in the laboratory, right? We found this result, but we were able to control everything. Out in the real world, you can't control all that stuff, so we're still going to find the same results. That's a legitimate question, right? So in the real world, well, that's the real world. There's no laboratory there. It's going to be very hard to control these outside types of variables, and that makes the findings more realistic. But it also, it's a double-edged sword, right? Both of them, both settings are a double-edged sword. In the laboratory setting, you're getting all of this great experimental control, but you're lacking realism. In a field study, when you're doing the experiment out in the real world, you're lacking all that experimental control, but you're getting the realism. So it's kind of a trade-off there. So the advantage, of course, with field research or field studies or field experiments, whatever we want to call them, are that people are more likely to just act how they normally would, because they're not in a laboratory. They're in the real world. The disadvantage, of course, is that we give up a whole bunch of experimental control, and we can't ensure that both groups are being treated equally, or that there's even consistency among participants. So maybe there's something else happening in the real world that is interfering with our results. We're going to revisit that in a moment here. We're kind of just laying the groundwork for what we call internal validity and external validity. Okay, so when it comes to the different types of variables that are involved in an experiment, we talked about these a little bit, but let's go full force here. So typically, the two variables we're most interested in for an experiment is the independent variable and the dependent variable. So independent variables are variables that we manipulate as researchers. These are the things that we're interested in like what's going to happen if I do this to this variable. That's the independent variable. When it comes to dependent variables, these are variables that are measured to determine whether what we just manipulated with the independent variable actually had some kind of an effect, whether it changed anything in what we were interested in. So going back to our depression example there, does giving somebody Prozac, right, that's something I'm manipulating. I'm going to give half people Prozac, half the people are not going to get anything. If I manipulate this variable, is it going to affect their depression, right? So in other words, is depression dependent, at least in my study, right? Is depression, people's depression scores dependent on whether or not they got Prozac? So the medication is something that I manipulated. Their depression score is something that I'm going to measure. So independent, dependent variables. We also have things that are called subject variables. We could also think of these as individual differences variables. So these are variables that characterize pre-existing differences that exist among study participants. We're all unique in some way, even though we're really similar in lots of ways. We're all unique. Anyone who's had cats or dogs or any other type of pets, you know, cats do cat-like behavior. They do cat things. They knock shit off the table, they scratch you, they do all this stuff, right? Dogs do dog things, right? But every cat you've owned has been unique, right? They had their own personalities. I mean, Jane Goodall, if you're not familiar with her work, please just go check out, you know, some of the work that she does. Even if you're not that big into animal psychology, or animals in general, it's fascinating type of work. And she did not necessarily use experimental methods to come up with the wonderful research that she's done. But she said, you know, after decades of studying chimpanzees, said anyone who's, you know, owned pets, cats and dogs, know that they have their own personalities, their own idiosyncrasies, right? We're all unique in different ways, even if we're similar and predictable in other ways. But sometimes these individual differences can actually affect the dependent variable that we're interested in. Some of these individual differences might actually be causing differences in depression, and not necessarily the medication that we're trying to study, right? So we need to take some of those things into account. Now, one thing that, or one term that I'm sure you've heard of, this is something you're definitely not new to, this idea of statistical significance. You've heard it. You might not understand exactly what it means. But statistical significance refers to, well, let me just start off by saying, in the behavioral sciences, which we're in, we use statistics as tools. we use statistics to basically allow us to determine the likelihood that our results, the results that we got in our study, what are the chances, or what is the likelihood those results would have happened just by chance, just by randomness, right? Everything is possible, right? There's a probability that can be associated with anything in this world. There's a possibility that a black hole might just open up right at this very moment and swallow the entire universe. It's incredibly unlikely to happen, but it's certainly possible, right? There's a possibility that anything can happen. Just the probability of certain things happening are incredibly low, right? I might wake up tomorrow with superhero strength or superhero abilities. I don't know, right? That's possible. Is it probable? No, not at all. That would be incredibly unlikely to happen, right? So when we talk about statistical significance, we're asking, all right, I just found these results. I just did this study and I found these results. What's the probability that these results have nothing to do with my independent variable, have nothing to do with my study? What if I was just going to find these results anyway, just due to chance factors alone? That's what statistical significance is all about. So for our purposes, for psychological research, social behavioral research, we want what's known as a 95% confidence rate, meaning we want to be at least 95% sure that our results were not due to chance alone, that our independent variable actually did affect our dependent variable, that this wasn't just due to randomness. So if 5 or fewer times in 100 possible outcomes, the results are quote unquote statistically significant, meaning that if there's less than a 95%, less than a 5% chance my results would have happened just by chance alone, then we're going to go ahead and say my results are statistically significant. Does that mean my results are 100% correct? No, absolutely not. Just to go back to my legal analogies, I'll do a lot of those because that's basically the second part of my scholarship here. This burden of beyond a reasonable doubt. In order to convict somebody of a crime, a felony, you have to do so beyond a reasonable doubt. You have to be certain they're guilty beyond a reasonable doubt. That does not mean beyond all doubt. It means a reasonable doubt. And legal scholars have actually, and not just legal scholars, the legal system has kind of accepted or taken on the notion that reasonable doubt means you should be at least 95% sure. So believe it or not, beyond a reasonable doubt and statistical significance are almost the same thing there, right? For a jury, they have to be at least 95% sure this person did it. They don't have to be 100% sure. For us, we have to be at least 95% confident that our results weren't due to chance alone. We don't have to be 100% confident, though. Right? So, now, what does that mean? Well, it means if you do 100 trials, and they all end in convictions, then that means 5 innocent people are going to be convicted. what does that mean for us? Well, it means if we do 100 studies and they all are statistically significant, 5 of them are, those effects are not real, right? At least 5 of those studies, those results were due solely to chance events. So there seems to now be more of a growing emphasis on replicating research findings and using other statistical techniques such as effect sizes and even Bayesian types of approaches, which we won't get into now. But I want to show you a quick video that's going to highlight the importance of probability and, the very real, let's say, effect that, or the real concern that even very improbable events can pose to us, because the likelihood of you existing or of me existing, the likelihood that either you or me would be born, is so incredibly close to zero that it almost might as well be zero. But you and I are both here, right? Unless this is all some type of computer simulation, but then you'll have to take my cognitive psychology class for that. But for now, we'll focus on the statistical improbability of you existing. You shouldn't exist. Neither should I. The chances of us coming into existence are so incredibly small, but we're here, right? So let's watch this video and not get too freaked out by it. It's still a methods section, or methods chapter that we're talking about here, but I think it's important.
Hey there, welcome to Life Noggin. You are one of 7 billion people living on Earth at this very moment, and you are one of the 100 billion Homo sapiens to ever have lived here over the course of history. And that, my friend, is pretty amazing, especially because the probability of you existing at all is incredibly low. If you were counting, that was 2 incrediblies. See, in most cases, in order for you to be alive, your parents had to meet. Assuming that your mother could meet, let's say, 1 new person a day during her prime dating years, she would have met around 10,000 people, which, in her time, was about 0.00025% of the world's population. But because of geographical reasons, if we limit her available bachelors to about 5% of the world population, she had about a 1 in 20,000 chance of meeting your dad. Not super likely. And that's just them meeting. To have you, the two have to talk to each other, although not necessary, go out on a date, although not necessary, and eventually conceive a child. And the chance that that combination of sperm cell and egg turns out to be you is inconceivably small. See, your mother has about 300,000 eggs left by the time she reaches puberty, and will only release around 300 of them. Furthermore, men produce hundreds of billions of sperm cells in their lifetimes, any of which could reach that egg. Feeling pretty rare yet? Or slightly weirded out? And keep in mind, you existing doesn't just depend on your parents, it also depends on your parents' parents, and their parents, and the parents before that. You see where I'm going? And even more, if you want to get into the physics of life existing, it all depends on the finely tuned physical constants, like the electric charge, the gravitational constant, and even the dimension of space-time. If any one of these were different, incredibly important atoms like carbon would either be too unstable, or the electrons would collapse into the nucleus. And if there's no carbon, macronutrients like proteins, lipids, carbohydrates, and nucleic acids would not exist. And therefore, neither would you, my friend. Well, isn't that a lovely thought to end on? Leave me a comment about something you're grateful for, along with anything else you want me to talk about. Hey there.
Okay, so hopefully that was pretty neat for you, and maybe you have thought about that before. But yeah, the probability that either one of us would exist is inconceivably small. I mean, 0.00000, how many zeros you could think of? 1. But here we are, right? So given enough time and given enough possibilities for something to happen, it's gonna happen, right? No matter how improbable it, or even unimaginably improbable that event is. Okay, so this idea of statistical significance is actually related to a concept that I mentioned briefly earlier, and that's this idea of internal validity. So we'll see that there are multiple types of validity. The big ones are internal validity and external validity, at least when we're talking about the integrity of an experiment, let's say. So when we talk about internal validity, this is the degree to which we're reasonably confident that our independent variables actually caused effects on the dependent variables, meaning that we're reasonably confident that any changes we saw, let's say in our example of depression, that any changes in depression we saw were actually caused by the independent variable, our medication, our Prozac, and not some other variable that we didn't measure. So confounding variables are a serious threat to internal validity. And confounding variables are other variables other than our independent variables, so variables other than our independent variables, that systematically have an effect on the dependent variable. In other words, these are variables that, how do I put this? I'm just trying to think, like, for our example of depression. Let's say that in our study of depression in Prozac, the effect of Prozac on depression, we had 100 participants, remember. We split half of them and, randomly assigned half to get Prozac and randomly assigned the other half to get a placebo, a sugar pill, right? What if it turns out, though, that the people who ended up in the Prozac group were also in therapy on the side? Let's say they were doing cognitive behavioral therapy or any type of therapy, psychoanalysis, anything. And it turns out that all the people in the placebo group, they were not in therapy, right? Okay. We run the study and it turns out, hey, Prozac seems to do a really good job at lowering depression scores. Except, can we make that statement? Can we make that claim? Because we have a confounding variable right now, right? It turns out everyone who got Prozac was also in therapy. And everyone who was in the placebo group who didn't get anything, none of them were in therapy. So now we don't know if Prozac actually had an effect on depression or if being in therapy was what had an effect on depression. So we're dealing with what is known as a confounding variable. A confound is an extraneous variable, right? An extraneous variable is any variable that can affect our dependent variable, other than our independent variable. What makes a confound different is that it systematically changes with the independent variable. So in this case, the therapy is a confound variable because it systematically changed with our independent variable. Those who ended up in the Prozac group were all in therapy, right? And those who ended up in the placebo group, none of them were in therapy. So it was systematic. An extraneous variable tends to be less systematic. It tends to be more random. And there's a way to control for extraneous variables through random assignment. But we'll return to that in a moment here. So internal validity is all about, are you really sure that your independent variable caused changes in the dependent variable? Did it really? Are you sure it wasn't something else that did it? You sure it's not just extraneous variables? sure it's not a confound that you got in there somewhere, right? So one way to help ensure that that our independent variable really did cause our dependent variable is through the use of control groups, right? Make sure that we have control groups to kind of help rule out other explanation for the results. I gave you a pretty extreme case of an extraneous variable with therapy and Prozac. If we use true random assignment, the chances of that breakdown happening would be incredibly small, right? Because through true random sampling, everyone who's in therapy, we should have had about half of them end up in the Prozac group, half end up in the placebo group, and then the effect of therapy would have canceled itself out. So that's the importance of random assignment. But sometimes confounds will still pop up, right? Again, having a control group to make sure that, yeah, everything was kept the same between my treatment group and my control group. They were exposed to everything exactly the same. The only difference was one got Prozac and the other didn't. That will help with my internal validity. That will help with the certainty that it was the Prozac that had an effect on the depression. This is why blind studies, and particularly double-blind studies, are important. So a blind study is when either the researcher or the participant doesn't know which group they're in, right? Typically, when we speak of blind studies, it just means that the participant doesn't know if they got the Prozac or if they're getting the sugar pill. A double-blind study means that the researcher doesn't know either. And the researcher, meaning the researcher who is doing the measurements. Why? Well, because there's this idea of, whether we call it observer bias or experimenter expectancy. It's the same type of bias that can be introduced. If I know that a particular person is in the Prozac group, I might unconsciously, unwittingly, unintentionally rate their depression scores lower, right? I might see more improvement in them. Why? Because I'm expecting them to be doing better than the person who is not on Prozac. Again, experimenters, researchers are human. We not only are capable of being biased, we try very hard, or we should try very hard, to recognize our biases and put some protections in place. So a double-blind study means the participants don't know which group they're in, and the researchers don't know which group they're in either. So double-blind studies, especially when it comes to medication studies, drug studies, like I've been using as an example, are incredibly important. Okay, so internal validity, if that refers to how well or how certain we are that the independent variable actually caused the dependent variable, external validity is concerned with, well, what's the likelihood that these results are going to hold up under different conditions? Because we just did this laboratory study and we were making sure that both groups, had the same diet, that they had the same exercise regimen, that, both groups had an equal number of people who were in therapy. We had all of this experimental control in that laboratory. So much so that we kind of created an artificial world, an artificial reality for these people to live in. And that's great. So Prozac works under these very strict controlled conditions. Does it work in the real world, right? What happens when we start giving it to people outside of a laboratory, outside of this controlled type of study. So external validity is concerned with whether the results obtained under one set of circumstances and one set of controls would occur in a different set of circumstances, or under a different set of controls, or under no controls at all, right? So external validity considers the representativeness of samples. Again, we typically don't use true random selection for experimental studies. At the same time, we try to make our studies as representative as possible. But we often end up using what are known as convenience samples. So convenience samples, what are they? Well, kind of as the name suggests, these are the people who are most convenient to use. Oftentimes that's undergraduates in college. And if you've taken Psych 100 here at Oneonta, you had a research participant requirement. You had to be a participant in research, right? So that was the subject pool. You were part of the subject pool and you chose which study you went to. That's about as convenient as it gets. There's debate on whether or not research that's conducted with undergraduate participants is representative of the general population. Can we really apply these results that we get with these undergraduate students to people who are not undergraduate students, like people who live in different parts of the country and who are of a different generation, a different socioeconomic class, so on and so forth? The general answer is the research suggests yes. Again, because we are more interested in studying the effects of manipulating a variable, and less on the effects of let's say the effects of individual differences on a variable. In other words, regardless of your race or gender or socioeconomic status or what region of the country you're coming from, the biological processes that exist between all of us tend to be the same. And even a lot or most of the psychological processes, cognitive processes that exist between us tend to be the same, more similar than not. So research, and people have a very good point, very valid concern in saying, I don't know, using college students, is that a good sample? Probably not the most representative, but research that takes those studies that uses college students and redoes them, replicates them using more diverse samples, shows that the effects tend to stay the same. They tend to hold up, right? That being said, you want to make sure that your sample is as representative of your population of interest, the group of people you're most interested in studying. So that often means ensuring that there's enough diversity in your sample, right? So typically speaking, as social psychologists, we're going to want to try to make our sample as close to the breakdown of the general population as possible. So that might mean we want to make sure our sample is 50-50 when it comes to males and females. When it comes to the portion, well, transgender folk as well should be represented, depending, of course, on what exactly you're studying, you might want an even larger proportion of your sample to be made up of transgender folk. But transgender people make up a very small percentage of the overall population. The same goes with LGBT participants, gay, lesbian, bisexual participants. Generally speaking, there tends to be more bisexual people than there are gay or lesbian people. They make up a significant but small, again, percentage of the population. But if you're studying a topic that is inherently related or would have some type of meaningful significance to these populations, you want to actually make sure that they are overrepresented. But when it comes down to, the breakdown of race, you want your sample to look like your population, right? And the same goes with socioeconomic class and so on and so forth. There's some other things that we can do to try to make our experiments have more external validity. The first is known as mundane realism. So mundane realism is how much the research setting resembles the real world setting of interest. In other words, how much of your lab, how much does it actually resemble what a real person would experience if they were doing this study or participating in these activities in real life. Let me give you a few examples. So for me, I do a lot of legal decision making, jury decision making. So in an ideal world, I'd have a mock courtroom that would totally look like a court, with the judge's bench and the flags and all that stuff, so that people would feel like they're in a courtroom. One professor that we had here a few years ago, she was interested in perception and sensation, and she did a lot of research involving I don't know exactly what she did because some of it was way over my head here, but taking a look at different frame rates of movies, and she had some space. It was much easier for her, much cheaper, right? She got some big comfy chairs and gave participants soft drinks and popcorn, and she kind of made it feel like a movie theater type of experience. These would all be examples of, say, mundane realism, kind of making the experimental setting as realistic as possible. We also have what's known as experimental realism, and this is how compelling and real the experimental situation or process is to the participants. So again, here's an example in my own research. So there's a lot of different ways that you can do jury type of research. One way is to just write up a short vignette, paragraph long, about some type of crime or something, have participants read it, enter a verdict, and answer a bunch of questions. That's not very realistic in terms of procedures wise, right? So in addition to having a mock courtroom, an actual courtroom in the building in Fitzell somewhere, that would be so freaking cool to do. But something short of that, I at least try to have as much experimental realism as possible. So instead of having participants just read a short blurb, a paragraph or two, I actually print out like a trial transcript. So they have to go through and read through a trial transcript. It's an abbreviated one, but it's still 14 pages long. It's still significant. And there's opening statements in there from both sides. There's direct questioning, cross-examination. Depending on what I'm doing, I also will have participants break up into small juries and deliberate. Ideally, this is what we did in graduate school when we had access to money and space. I went to, my graduate program was at the Graduate Center, but I worked at the Legal Decision Making Lab at John Jay College of Criminal Justice, and they actually did have, they had like two mock courtrooms in there. And we actually, instead of having participants read a description or read a trial transcript, we spent weeks actually filming. We hired participants to come in and we filmed these 1 hour, 2 hour, 3 hour long, depending on which condition you were in, mock trials. So we had like people sitting in a courtroom setting on a big screen watching a trial with actual lawyers doing back and forth type of stuff. So that would be an example of experimental realism. Are the procedures real, right? Or as real as possible? You know, I can't do video mock trials for every study that I do, but you do the best you can, essentially. Okay, so deception in research, using deception in research, essentially lying to participants or not being 100% truthful there. So sometimes this is necessary to do. Why? Well, it can add realism to an experiment. Studies have shown that participants are rarely bothered by the use of deception. Most of the time, they actually think it's kind of cool. Like, oh wow, I didn't know that's what this study was about. But it does raise some ethical concerns, right? If you're deceiving your participants, then there's an issue about whether or not they offered informed consent. Did they really agree to participate in your study? Because they participated in the study you said they'd be participating in, but you're using deception in that research, or in your study. So the study that they agreed to is not actually the study that they're participating in. And we bring this up because, of course, ethics is very important, but also some of the major big, historical types of studies that we read about, particularly in this class, social psychology, use deception in them. And they made use of what are known as confederates. So confederates are people who are working for the researcher who act like they are participants, right? So other participants think that these confederates are just other participants, right? But they're not. Those confederates are actually working for the researcher, and they're in on the study, right? So keep that in mind, because we'll definitely be talking about that. That'll definitely come up throughout the semester. A lot of the really kind of cool historic studies that we'll be talking about probably could not be done today because of some ethical issues there. We also have this method called meta-analyses, and this is not something we have to get into too much for this class, but just know that it exists. So meta-analysis involves taking several studies that have examined the same thing. So let's say you have 4 or 5, or not 4 or 5, let's say you have 20 or 30 studies about whether or not contact between members of different races has an effect on reducing prejudice. Well, each study did something a little differently. Each study might have been done at a different time. Maybe there's several years or even decades that separate these studies. Each one might have analyzed the results in a different way. So what a meta-analysis can do is basically take the results from all of those studies and compare them to find out overall, so across 10, 15, 20, 30, 40, 50 studies, what did we find overall, right? Some studies are going to show there's no effect. Some studies are going to show there's a huge effect on reducing, say, prejudice when there's contact between members of different races. Some studies might show, hey, it actually makes it worse, right? So a meta-analysis is going to compare all of those studies and see overall across 30 studies what is the main effect, what's the takeaway from all of these studies. So that can be, particularly helpful, especially when we're dealing with, again, these constructs that we're dealing with. There's no real easy way for us to measure a lot of the things that we're interested in studying. Okay, so culture and research methods. Your book speaks about this as kind of an issue of external validity, right? So that research findings in one culture don't necessarily generalize to another culture. We'll see examples of this more and more as we make our way through the material for the course. But something like the fundamental attribution effect seems to be more of a Western society type of phenomenon compared to, say, more of an Eastern or collectivist type of societies. We don't seem to see the same effects, or even sometimes when we see similar effects, they don't tend to be as strong, right? So we need to take culture into consideration. We'll see for the next chapter when we start talking about the social self. We'll see how important culture is in terms of defining who we are. Also, context of questions and the assumptions that respondents make can influence responses. So this is kind of what we spoke about before. The way that you word certain items on a survey can certainly influence the way that people respond. But from a cross-cultural perspective, different questions, or even the way that you ask certain questions, can be taken differently depending on the culture that you're dealing with, right? So in our culture, Western culture, or the United States at least, making this sign, this is okay sign, right? In some cultures, this means asshole or go fuck yourself, right? More recently, we see that making that sign is actually, used in a different way, in a different position, is used to express white supremacy. And that started off, from what we could tell, as just a hoax on 4chan, just a bunch of, Twitter, or a bunch of internet trolls that people actually adopted and made it a real thing, even though it was supposed to be bullshit. People have taken it on. So depending on the culture, different questions, different symbols, different words, the way you phrase things can mean different things. And when it comes down to saying, okay, well, I have this scale and it's been standardized, I've tested it out, why can't we just translate it into whatever, into Russian or Chinese or anything like that? Well, effective translations can actually be really difficult because we're not dealing with legal documents here. We're not dealing with even just pure information like we're dealing with now with this lecture or this class. When we're dealing with these types of surveys or these types of questionnaires, and we're trying to get to people's beliefs or their attitudes or their feelings or their motivations or behaviors, the subtleties of words can make a huge difference, right? In terms of how people might respond. Also, multilingual people may think or act differently based on what language you're asking these questions in and the setting in which they're in. So even people who can speak multiple languages, depending on which language you're asking these questions in, you might actually get different responses. Again, because of the subtleties of the differences that might exist in some of these words that we use. Okay, I'm going to try to speed it up a little bit here. We're at an hour and 5 minutes, so let's try to do another 10-15 minutes to finish up. So ethics and values. So researchers have a moral and legal, very often, legal responsibility to abide by ethical principles. The use of deception is a concern in social psychology, and it's often used only as a method of last resort. So trying to get approval to use deception in an experiment, you're likely to run into some difficulty for it. Trying to get it approved, some difficulty. The Institutional Review Board, which we'll talk about in a moment, it's basically an ethics board, is going to ask you to find another way to do it. And it's basically up to you to show that there's no other way I can do this study except to use deception. So again, it's used as the last resort, tactic of last resort, and not only do you have to show that there's no other way to do the research but to use deception, you also have to make a convincing argument that the disadvantages or the problems associated with using deception are outweighed by the benefits that can come from your research. So it's pretty high standard for using deception. Ethical reviews are required for social psychological studies, all research involving human subjects, not just social psych studies. So ethical reviews are required before you could start collecting a single piece of data, right? So who does these ethical reviews? Well, institutional review boards, also known as IRBs. And one of the main things that IRBs are going to be concerned with is this issue of informed consent. Institutional review boards are an ethics board. Their purpose there is to ensure the safety and well-being of your research participants. And there's good reason for that, because psychologists and researchers in general, using human participants, have done some pretty horrible things to their subjects. I mean, there's some things that we should not be proud of in our field, right? But in 1974, the U.S. Department of Health, Education, and Welfare established regulations to protect human participants in research, and this involved the creation of institutional review boards. Institutional review boards, any organization that receives any type of federal funding, even if it's indirect type of federal funding, if you want to do any type of research, you must have an IRB. And IRB are made up of people within the institution, but so let's just say, for example, at Oneonta, our institutional review board, I believe there's 10 or 12 people. They're usually between 10, 13 people on the institutional review board. They're made up of faculty members. You also have a student representative, and you have a community representative. So somebody from not associated with the college that is there, and they receive training that is provided through the U.S. Department of Health, Education, and Welfare in order to serve on the IRB. And you get training in ethics and training to be able to identify potential ethical concerns. So we must abide by these research ethics established by the IRB, but also by professional code of ethics. The American Psychological Association, the APA, has their own ethical guidelines that involve not only just the treatment of human participants, but also the treatment of data and how we go about publishing and presenting our research in ethical ways. So I said before, an important component of getting IRB approval is going to be informed consent. So what is informed consent all about? Well, as the name suggests, it means that participants understand what is involved in the study, and that you have made them knowledgeable enough that they're able to make an informed decision about whether or not they want to participate in your study. So there are some methods that might not require informed consent, particularly observational studies where you're not going to have any type of interaction with a participant. You might not need informed consent, right? Because you're just watching. Archival studies, like we spoke about before, might not need informed consent because this is data that is usually just publicly available. However, it's not up to you as the researcher to determine whether you need to obtain informed consent or not. The IRB will determine that. Okay. Another component of the IRB process and the research process in dealing with human participants is debriefing. So debriefing, informed consent occurs at the beginning of the study before you collect any data. Debriefing occurs at the end of the study, at the end of a participant's participation. So what typically happens during debriefing? Well, you inform the participant, you give them a better, more detailed explanation of the study that they just participated in. So during informed consent, you don't want to let the participant know exactly what it is you're testing. You don't want them to know what your hypothesis is, because that might influence how they respond. That might influence your results that you get. You give enough information in the informed consent process that they understand what's expected of them, how much time it's going to take, are there any risks to them, are there any rewards or benefits to them, that they understand that this is either confidential or anonymous, their participation, or how their data is going to be stored, how they're going to be protected, so on and so forth. The briefing at the end, once the study's completed, you can actually go ahead and say, yeah, this is exactly what it is we were interested in studying, and let them know about all the procedures that were used. Some things, they might not know that they completed an implicit bias test, right? If they might thought they were just pressing a bunch of buttons on a keyboard. You might say, no, actually that was an implicit bias test. So this is your time to really fully explain the study, what happened and why. Why did you do it? What was the purpose of the research? And how those results are going to be used, right? So say, yeah, we might, present this. We might try to get it published. Hopefully it'll lead to a better understanding of X, Y, and Z. The briefing is particularly important if you used any type of deception. So if they were Confederates, you have to let your participants know. Yeah, those two people who you participated in the study with, they were not students. They work for me, right? They work for the research team. Or at the beginning of the study, we told you it was about people's moods and how it affects their recognition of names. The study was actually about X, Y, and Z, right? So debriefing is the time to tell the participant what the research was about, particularly if deception was used, and if they're upset about that deception, the debriefing is your time to get them unupset, to kind of explain why they had to be deceived, why it was necessary in order to conduct this study. Again, most people don't have a problem with deception. So some ongoing debates and controversies. This idea that, ethical principles are based on moral values, and moral values can change, not just over time or cross-culturally or between generations or what have you, but between individuals. We all have different sets of moral values, right? But the ethical principles are based on those values, and they can change. So we need to ask, though, whether these values affect science in other areas, in areas other than, say, ethical issues. Meaning, can science be totally unbiased and objective? No, it can't, right? So we try our hardest. As scientists, it's your obligation to be. And, depending on what class I'm teaching, I would say, well, it's my, obligation to be unbiased as a professor as well. Not if I'm teaching a class on social issues or something. And then I kind of think it's, my obligation to inform you of my biases so that you understand, where this information is coming from. I'm human too, right? And not going to say I understand or recognize all of my biases, but certainly ones that I do recognize, I take active steps to try to control for them. And that's kind of the best that we can do as scientists. But it doesn't mean that, science is completely unbiased or completely objective. Science is done by humans, and we're objective creatures. We're biased creatures, right? We do the best we can, and we admit and disclose these biases. There's also a question about how should values affect scientific inquiry. This is particularly an issue when it comes to topics that might be political, or if the results of your study can have a negative effect on a particular group of people. Not just a group of people, but let's say a historically marginalized group of people. Could your research be doing damage to, or can it hurt a group of people? Can it hurt? Can it? That's the word I'm looking for here. Can it lead to further marginalization? Can it set our society back in terms of progress that we've made on certain social issues? This is a bit of a conundrum for science, right? Because ultimately, science should only be concerned with truth, facts. That's it, right? Science is not supposed to be concerned with how the results are going to be used. We're only concerned with finding the truth. But listen to that statement. That's kind of brutal in a sense, right? But that is the responsibility of science. There's debate whether, though, research that might be detrimental to society or certain groups within a society, whether that research should be done at all. And there's no easy answer to that, right? Again, one of these moral dilemmas. Okay. Also, the issue of self-protection against intentional and unintentional bias and dishonesty. When it comes to bias, intentional bias, you got no business being a researcher if you're intentionally going to be biased. You got no business being in the sciences. You got no business being in a lot of, I'm saying, any profession. If you're going to be intentionally biased, except maybe politics or something like that. It's more an issue of the unintentional biases that I'm concerned about. That researchers don't always know that they're not as objective as they think, right? Or not as unbiased as we would like to think that we are. The issue of dishonesty, of course, is one that plagues every profession. People lie, cheat, and steal everywhere. So this is not limited to the social sciences, for sure. The good thing is that, if you're ever caught lying, cheating, or stealing, as a scientist, caught faking data or doing any kind of shady shit like that, you're not going to be a scientist anymore. Like, that's just the end of your career right there. And if you are a scientist and you're aware that a colleague of yours is engaging in some shady shit, you don't say anything, guess what? You are no longer going to be a scientist. Like, your career is over. So we do not play around when it comes to that stuff. Why? Well, because even though it's rare, right? When it does happen, when this type of dishonesty and faking data and all that stuff, when it does happen, it makes the news. And the last thing that any scientist would want or should want is for people to lose faith in science. Take a look around us right now. Like, there's already this type of anti-science sentiment going on. It's all around us, right? So we don't put up with that shit. And yeah, you're expected to turn your mom in, right? Like, there's no exceptions to this rule. You can see how that's actually quite different from other types of occupations. And if you're interested in social psych, and maybe you will be by the end of this semester, consider taking my applied social psych class, because one of the issues that we're dealing with in society, of course, is police culture and some of the problems that exist within police culture. And I would argue, I do argue in my applied social psych class is that it's the protective fraternal nature of policing that is most detrimental. Right? It's that you do not snitch. So I come Irish family from Long Island. Like everyone felt my family. It's a cop. I grew up around this culture. I know this culture, and it's not a good one, right? Because you can witness your patrol partner do some really bad shit, and guess what? If you say something, you're no longer a cop. That's just the way it is. This is a fraternal type of mentality. And I think that if the police take on more of the mentality that we have as in the scientific community, things would dramatically change for the better. But we'll save that for another time. I want to end this lecture by showing you something that I saw in The Onion on Twitter. And if you're not familiar with The Onion, it's a satirical newspaper, so it's all, fake, and they're funny as hell. And, they make some really good political and social observations and they target everybody. So don't, but I thought this one was particularly funny, right? So, again, from The Onion, the headline is Report: Majority of Psychological Experiments Conducted in the 1970s Were Just Crimes, right? And it says, after analyzing hundreds of academic papers from the decade, we found that 79% of these experiments served no scientific purpose, but in most cases were conducted simply to inflict pain and distress on their test subjects. Again, this is satire. This is not real. It's meant to be funny, tongue-in-cheek. And I include it here because we were just speaking about research methods. And I said to you, we're going to examine some pretty classic and powerful social psychological studies that could never be done today, or would very likely not get IRB approval, but they were done during the 1960s and 70s. So that's where this headline is coming from. I thought it was fitting to end this lecture with that. Okay, so next week we'll start talking about chapter 3, which deals with the social self. So I shall see you all then. Take care.